this moment, we have two areas I think I'm really excited about. One is that we're beginning to understand how aneuploidy, which is the incorrect number of chromosomes, actually drives cancer. We've learned that aneuploidy both drives cells to proliferate faster, but also allows them to escape the immune system. And what we've discovered is that the immune system gets tricked by aneuploidy. And if we can somehow understand how that works and reverse it, then we'll enhance the ability of these new cancer therapies to work. Another area that I'm very interested in is understanding the immune system and how it detects pathogens, and to develop methods that allow you to determine, what your immune system's actually seeing. We know it's happening, but we don't know what it's looking at. And so we developed this method called VirScan that allows you to just take a drop of blood and assay all of the antibodies in it for whether or not they recognize viruses. And so that lets you look into the history of your viral infections, because your immune system maintains a memory of every pathogen that has attacked it and that it's attacked back. And so we can now detect that. I think that one of the more interesting things that has happened, at least in the sub-areas that I'm familiar with, is the understanding of aging and how different parts of your body's biochemistry, which normally protects you from things like cancer and things like that, in the end actually hurt you. Because of the way evolution works, things are selected to exist based on how well they help you survive and reproduce up to a certain age. Beyond that, that has not been selected for. And there's a process called cellular senescence, which is a response that cells that are damaged take on. Now, sometimes those cells just die, but sometimes they differentiate and they leave cell cycles, so they'll never proliferate again. And this prevents them from becoming a cancer later on. So this is a tumor suppression mechanism. Well, it turns out that those cells accumulate in your body as you age, and they also induce inflammation. And this is deleterious later in life. And it's been linked to all kinds of aging diseases. And recently, someone did an experiment that was really remarkable. They engineered a mouse such that they could, when they wanted to, kill the senescent cells. And those mice lived 25% longer and looked better. So they didn't age as rapidly. And I think that is something that is really exciting, and that, suggests that there will be ways to mimic that. That's a trick they use genetically. But with a drug or something like that, in the future, you might be able to actually extend health and prevent, not necessarily forever, but delay at least a lot of the diseases of aging.